Okay, so this video is going to cover completing the square. What completing the square does is it allows us to solve quadratics that have a b term but are not perfect square trinomials. So this is not a perfect square trinomial. So what we're going to do is we're going to actually get rid of that 10 at the end of the equation because that's what's causing this to not be a perfect square trinomial. So I get rid of the 10, but I want to fill in the missing spot next to the 8x with something that would make it a perfect square trinomial. Meaning that if I were to do my box method, I'd have x squared in the top corner, I'd break apart my 4x, and I want to know what number belongs in this bottom corner to make it a perfect square. So if this is x and 4 and x and 4, that means that the missing number has to be 16. So I'm going to add 16 so that on the right-hand side, or the left-hand side, I have a perfect square binomial. But if I'm going to add something to one side, I must add that same thing to the other side. So I'm going to rewrite the left-hand side as the perfect square binomial, x plus 4 squared, which is now equal to 36, which I can then continue to solve using root method. So I'll take the square root of both sides, x plus 4 equals plus or minus 6, which would give me two equations, x plus 4 equals positive 6, and x plus 4 equals negative 6, which when I solve gives me x equals 2 and x equals negative 10. So just to recap the steps, first I subtracted 10 from both sides to get rid of the non-perfect square. Second, I added the perfect square to both sides. Third, I wrote the perfect square trinomial as a binomial. And fourth, I used root method to solve the equation. Those are my 4 steps. So to get that missing number, that perfect square, what we essentially did is broke b into half and squared it. So if I give you x squared minus 10x plus 42 equals 10, again, the first thing that I'm going to do is get rid of 42 because it's not a perfect square. That's going to give me x squared minus 10x plus some magic number equals now negative 32, which I'm going to add the same magic number to. So the magic number is going to be b divided by 2, so negative 10 divided by 2 squared. So my magic number is going to be 25. So that's the second step that I then do. I add 25 to both sides. My third step is to write my perfect square trinomial as a perfect square binomial, so x minus 5 squared equals negative 7. And then to solve using the root method. So I'm going to square root both sides. And I actually can't take the square root of negative 7, so this is going to have no real solutions. The last very important thing for completing the square is that a must always equal 1. So the last two examples, a was equal to 1. For this next example, 2x squared plus 32x minus 64, that is not, a is not equal to 1. So my first step here is to actually make a be 1. And I'm going to do that by dividing every single thing by 2, which gives me x squared plus 16x minus 32. I'm going to add 32 to both sides, and I'm going to get x squared plus 16x plus something equals 32 plus that same thing. So to find my missing number, I take half of b and square it. So that's going to be 64 in this case. So 64 is my missing number. And so my right side adds up to 96. My left side gives me x plus 8 squared written as a binomial. I'm going to take the square root of both sides, and I get that x plus 8 is equal to the square root of 96, which is 9.8 actually, when we round up, plus or minus. And so my two equations are x plus 8 equals positive 9.8, which gives me that x is 1.8, or x plus 8 is negative 9.8, which gives me that x is negative 17.8. So those are my two values of x.